Hey everyone, welcome to this explainer. Today we're going on a bit of a journey. We're starting with a massive, literally world-changing issue, the global climate crisis. And we're going to zoom all the way into a microscopic, incredibly innovative, life-saving solution. It's a perfect example of how cutting-edge tech can hit our biggest modern challenges right on the nose. Let's dive in.
Okay, picture this. A severe climate event has just occurred. Maybe it's an intense heat wave or devastating flooding, and it hits a remote, vulnerable community. People are starting to get sick. Now, here is the absolute million-dollar question. How do you test for a climate-driven disease when there's absolutely no hospital nearby? When you're miles, maybe even days away from the infrastructure needed to run traditional medical diagnostics, a delay in detection can literally be fatal. That is the exact high-stakes challenge that the innovation we're unpacking today aims to solve.
Section 1. The Climate-Health Connection.
You know, we often talk about climate change as just a weather issue, right? But it is increasingly framed as an escalating direct crisis for human health. According to the project proposal we're examining, we're seeing dangerous spikes in water contamination, a much wider and faster spread of infectious diseases, and a really alarming rise in respiratory disorders. And the kicker is, extreme weather usually wipes out healthcare accessibility right when vulnerable communities need it most. Because of this, developing countries desperately need diagnostic tech that is low-cost, incredibly fast, and portable. They need a way to figure out what is making people sick, and they need that answer immediately.
Section 2. A portable AI solution.
Before we look at the device itself, let's talk about the mind behind the innovation. The applicant for this project is Dr. Rawa Ahmed Faris Al-Sadeh, an assistant professor at the University of Baghdad. Now, the crucial point here is her specific intersection of expertise. She's a researcher specializing in laser applications, optical sensing, microfluidics, and AI-driven health tech. It takes exactly this unique, cross-disciplinary mashup of physics, biology, fluid dynamics, and computer science to engineer the kind of solution we're about to explore.
So, Dr. Al-Sadeh's proposed innovation is a portable AI-enabled microfluidic platform. Now, microfluidics might sound like some heavy scientific jargon, but essentially, it's a high-tech diagnostic laboratory shrunk down so small that it can comfortably fit right in the palm of your hand. It works by manipulating incredibly tiny amounts of fluids to detect specific health indicators. The whole system is designed from the ground up to be low-cost and portable, directly answering that immediate need for accessible healthcare in post-disaster scenarios. Section 3. Inside the technology.
Let's peek under the hood. At the scientific core of this device is something called nano-curcumin optical sensing. In simple terms, it uses microscopic particles of curcumin, and yes, I mean derived from the exact same compound found in the kitchen spice turmeric. It combines that with light to spot biological anomalies. This optical sensing allows the device to rapidly detect and monitor climate-linked health indicators down at a molecular level. It's just an incredible, highly practical use of nanotechnology.
Here's how all these complex parts actually work together in a simple workflow. Step 1, you take a minimal fluid sample from the patient. Because it's a microfluidic device, you literally only need a tiny drop. Step 2, that sample enters the device, where the nano-curcumin optical sensing immediately gets to work looking for danger signs. And step 3, this is where the artificial intelligence comes in. The system combines that optical data with AI and mobile or cloud-based analytics. The AI crunches the numbers, helps interpret the results, and provides predictive analysis for real-time health monitoring. Boom! You go from a single drop to an AI-predicted diagnosis in a matter of moments.
You can probably see how this fundamentally upends the traditional medical model. Think about it. Traditional diagnostics usually require large biological samples, totally sterile environments, big expensive machinery, and a highly stable electrical grid. In stark contrast, this portable AI platform needs minimal sample volumes, costs very little, and is entirely built for remote and resource-limited settings. When a climate disaster wipes out local infrastructure and power lines, the traditional model fails completely. But that is precisely when this portable model steps right in to save lives.
Section 4. The Iraq pilot.
To test this out, the proposal outlines that this system can initially be piloted right in Iraq. And they aren't keeping it in a lab. They're specifically targeting locations like schools, community clinics, and water monitoring centers. The goal is to place this tech directly into environmentally vulnerable regions that are already getting hit hard by extreme heat and pollution. By installing these devices in schools and community centers, everyday local institutions instantly transform into frontline defense outposts for early disease detection. It puts the technology squarely in the hands of the community.
Section 5. Scaling for global impact.
Now, the expected impact of this platform goes way beyond just its initial pilot. Long-term, it's about assisting governments and organizations everywhere with preventive health monitoring. In fact, the proposal explicitly notes that the proposed solution aligns with UNICEF priorities for scalable climate health innovation. This means the device has the potential to drastically improve healthcare access in vulnerable communities worldwide. It is built to be scalable, offering genuine hope for true global health equity in the face of a rapidly changing climate.
So we've gone from the massive, looming threat of climate-related health risks all the way down to the microscopic elegance of nano-curcumin optical sensing. And I really want to leave you with this final thought. If a pocket-sized AI lab can successfully protect environmentally vulnerable communities in Iraq from water contamination and infectious disease, how could it fundamentally change the entire future of global healthcare? Imagine what happens when every remote village on Earth holds the diagnostic power of a major hospital right in the palm of their hand. Think about that and what it means for our shared future. Thanks for joining me for this explainer. Keep learning, and I'll catch you next time.